All right, let's jump right in. Welcome to today's explainer. If you've ever looked at a highly complex machine learning model or a quantitative financial strategy and wondered how the researchers actually built their foundational logic, well, you are in the exact right place. Today, we're exploring the very architecture of research. We're going to trace the path all the way from abstract, grand philosophical ideas down to how central banks are literally using algorithms to spot microscopic errors in massive data sets. So, are method and methodology just two words for the exact same thing? We're starting here because, honestly, mixing these two up is incredibly common, both in academia and out in the industry. But grasping the difference is absolutely crucial. It's the first step to mastering any kind of research. If you confuse them, it's kind of like confusing the architectural blueprints of a building with the literal hammer you're using to drive in the nails. Here is our roadmap for today. 1. Blueprint versus tools. 2. Theoretical scaffolding. 3. Backtesting. 4. The data problem. And 5. ML solutions. Okay, section 1. Blueprint versus tools. Let's definitively separate methodology from methods. Think about building a house, or even just putting together some flat-pack furniture. Your methodology is your overarching strategy. It's the blueprint. It answers the why and the how of your approach. Are you the kind of person who meticulously reads the manual cover to cover before touching a single screw? Or do you take a more exploratory, figure-it-out-as-you-go approach? That underlying philosophy, that's your methodology. Methods, on the other hand, are your practical tools. The hammer, the nails, the Allen keys. If you're gathering data, your methods are your specific surveys, your interviews, or your statistical software. So methodology is the game plan, and methods are the tools you're used to execute it. Moving on to section 2, theoretical scaffolding. This is where we see how that methodology acts as a foundation. Scholar van der Waals hit the nail on the head when he described theoretical frameworks as the intellectual scaffolding underpinning research. When you're diving into social science or financial market analysis, you're dealing with incredibly multifaceted stuff. Without a theoretical framework, you're honestly just staring at a chaotic pile of data points. This scaffolding acts as an analytical lens. It lets researchers organize observations, map out relationships, and actually make sense of the complexity instead of just getting completely lost in the noise. And theory is actually built in layers, a stack, if you will. Way up in the clouds, you've got meta-theory, which is your underlying philosophical worldview. Just below that is grand theory, offering those broad perspectives like structural functionalism. Then we step down to middle-range theory. And this is crucial because it acts as the bridge connecting abstract ideas to empirical research. Finally, you zoom all the way in on microtheory, dealing with highly focused, narrow issues like specific managerial decisions. A truly robust framework pulls from all these layers. Section 3. Methods in action, backtesting. Let's pick up our hammer and see how we move from grand theories to specific execution. In quantitative finance, backtesting is the practice of evaluating a trading strategy using historical data. A recent study actually likened this to a doctor diagnosing a patient, which is a great way to think about it. Just as a doctor looks at your medical history to predict your current health, a financial analyst uses backtesting to retrospectively test their theoretical strategies against real market histories. They want to see how that strategy would have performed. Now, when quants run a backtest, they don't just look at the bottom line profit. They use a whole toolbox of metrics. They're checking the Sharpe ratio for risk-suggested returns, the maximum drawdown for the worst-case drop, and the overall profit factor. But the really important thing here is the relationship between these numbers. You can't look at them in isolation. For instance, the number of trades and overall performance have to be evaluated together. Why? Because a strategy might have an amazing Sharpe ratio, but if it only executed 3 trades over 10 years, it's just not statistically reliable. Context is literally everything. Section 4. The data problem. Because if context is everything, what happens when your data is broken? Central banks manage staggering amounts of data, and validating it is a monumental headache. A recent paper from the Bank for International Settlements pointed out that traditional data validation methods are really struggling today. Graphical methods, like visually inspecting charts, are way too time-consuming and prone to human error. Conditional controls, which are basic if-then rules, are too rigid and completely break down when the market fundamentally shifts. And cross-referencing alternative sources, great in theory, but incredibly hard to scale. These manual methods just can't keep up with high-frequency data sets. And relying on basic threshold rules leads straight into what's called the false negative trap. The BIS paper highlighted a wild example from 2019 involving the U.S. Secured Overnight Financing Rate, or SOFR. The rate experienced a massive, unprecedented spike. A rigid if-then rule would automatically flag that as a data error, a false negative. But a human expert, looking at the wider context of other interbank rates, would know it was a true outlier, a very real market event. But here's the catch. You can't have human experts manually validating millions of data points every single day. The whole system would just grind to a halt.
Which brings us to Section 5, ML Solutions. How do we automate that expert human intuition?
The Bank for International Settlements proposed a highly automated 6-step workflow to solve this. Instead of rigid rules, they input the data, check for gaps, and then use dimension reduction to find out what's actually relevant. In Step 4, the machine learning model essentially predicts what a target data point should be, based entirely on the context of the wider market that day. Then, it analyzes the prediction errors, and if a data point deviates wildly from the prediction, it assesses that specific error. It's incredibly smart. To prove how well this works, researchers ran an experiment on the Shanghai Stock Index. They injected a hypothetical error into the data that was exactly equal to the average daily percentage change. We are talking about a mistake so completely ridiculously microscopic that a human looking at a chart would absolutely miss it, and standard threshold warnings wouldn't even trigger.
But then they applied an unsupervised clustering algorithm called dbScan to the prediction errors. dbScan finds clusters of normal data and flags anything sitting by itself in space. Because the predictive model was so contextually accurate, that tiny injected error was isolated and caught immediately. And even better, if the market structurally shifts over time, the algorithm simply adapts and forms a new cluster of normal data. It dynamic proofs the data against evolving markets without needing a human to go in and rewrite the rules. So we've traveled all the way from the abstract philosophy of meta theory right down to unsupervised clustering algorithms finding micro errors. But the ultimate takeaway from this explainer brings us right back to our starting point. Machine learning, backtesting, big data, these are incredibly powerful methods, but they are just tools. They are the hammers and the nails. And they will only ever be as effective and as trustworthy as the methodological blueprint that's guiding them. So the real question you have to ask yourself when designing your own strategies is this. You might have all the modern tools, but do you actually have the theoretical blueprint?